In this video, we're going to go through a bit of a long example on your screen says perpendicular lines, but this basically is going to be an example that incorporates different things that we've learned so far, right? So your length of a line segment, points of intersection, right? A lot of different things that we've talked about. So it is meant as a point where we just take a breath, we consolidate some of the theory that we've gone through and just practice some application before we start fighting with circles. So this is a bit of a long question. It's broken into different parts. So let us just analyze what's going on, right? So essentially we, on a Cartesian plane, right, we have one line that I've drawn in red, and the equation of that line is 4y minus 5x minus 6 is equal to 0. So that's the equation of that straight line. We also have a line that's coming from the origin to meet that line at a perpendicular angle. So these two lines are actually perpendicular to one another. So the question says line A passes through points A, B, C, right, which we can see, and then line B passes through O, which is the origin, and it is perpendicular to line A. Okay, so we can see that. Cool. So first part of the question says calculate the equation of line B. Right. So what do we know, or at least when it comes to calculating the equation of a straight line, which is y is equal to mx plus c? We said we need two things. The first thing that we need is we need the gradient, right? We need the gradient, and once we find that gradient and we know a separate point on the line, then we can basically just use the gradient and that point to find the equation of the line. So if you have 2 points on the line, it means you can calculate the gradient directly, right? But for line B, all we got is, we know that it passes through the origin, right? Let's just mark that. We know that it passes through the origin. That I thought was going to be thicker than that, but whatever. But we also know that it's perpendicular to A. We don't have 2 points, we just know the 1 point. But this piece of information where we're told that it was perpendicular to line A is actually very important, because we know that when two lines are perpendicular, so when two lines are perpendicular, the rule is the gradient of the product of their gradients is supposed to equal -1. So if I take the gradient of line A and I multiply it by the gradient of line B, I should get -1. That would help me find the gradient of line B, which would then help me find the equation of the line. All right, so now, what is the gradient of line A, right? With line A, we were actually given the equation directly. So I can actually take this, right, and say, okay, 4y minus 5x minus 6. This is the equation. But in order for me to get the gradient, I need it to be in the form y is equal to mx plus c. So that means for this whole equation, I need to make y the subject of the formula. So move everything else to the right-hand side of the equation. So that's going to be 4y is equal to, when the -5x goes to the other side, it becomes positive 5x. Same with the -6, that becomes positive 6. But we're not done, because remember, in this form, your y is on its own. So this 4 also has to be moved. And since it's being multiplied, we divide both sides by that 4 to get rid of it. Right? That gives us the equation y is equal to positive 5 over 4 x plus 6 over 4, which is the same as 3 over 2. Right. So in this form, we can actually directly read our gradient. It's actually positive 5 over 4. So coming back to this rule then, it means the product of the gradient is, so the gradient of A is 5 over 4. If you multiply by the gradient of B, which we don't know, this is going to give us -1. So in order for us to find the gradient of B, we can make the gradient of B the subject of the formula. So move that to that side. Divide both sides by positive 5 over 4. It's going to cancel that 5 over 4 on this side, but it means 5 over 4 needs to come to that side now. All right. That then means the gradient of line B is equal to, if you throw this into your calculator, it should give you -4 over 5. So that is the gradient of line B. All right, cool. Sorry for the noise in the background. Okay, so now we have the gradient. And now when you have the gradient, we can then say, okay, let us now use the gradient and the point to find the C value. There's actually a shortcut in this case, because remember your C value is the point where it crosses the x-axis. The y-axis. And we can tell that it crosses the y-axis at point y is equal to 0. So we already actually know that the gradient, the y-intercept is 0. But let's just throw it into our equation. So at the point that we know, which is 0 and 0, right? So this is the point. We're going to use that point that we know. We're going to substitute the y value of that point, which is 0. That's equal to your gradient, which is -4/5, multiplied by your x value of the point, which is also 0. That should give you, plus c. That's going to be 0 is equal to -4/5 times 0. Anything times 0 just gives you 0. If you substitute, that does give you c is equal to 0. Therefore, the equation y is equal to -4/5x plus c, which is plus 0. So this is your answer. Okay, perfect. All right, I hope that made sense. That is only the first question. The second question says, point B is the point of intersection between lines A and B. So coming here, we can see that, okay, point B lies where the two lines basically meet. Calculate its coordinates. Now, in one of the videos, we talked about the fact that in order for you to calculate the point of intersection between two lines, you basically find the simultaneous equation of those two functions. So the two lines that we have are, I'm going to write it in this form actually, since this is easier when it comes to simultaneous equations. It's y is equal to +5/4, 5/4x, plus your c value, which is 3/2. Right, so that's your first equation. Your second equation, right, which is the second line that's involved in that intersection, is this equation, which we found in the previous question, which is y is equal to -4/5 rather, x. All right, so this one, in this case, we can just say, okay, in order for us to calculate the simultaneous equation, we're saying, okay, we have to equate the two y's. We're going to substitute. So we're going to take the y expression from the first one, which is 5/4x plus 3/2. That's equal to the second y expression. That's -4/5x. So we're going to try to solve for x. We're going to take this term to the other side and take this 3/2 to the other side. So this equation is going to become 5/4x plus, because remember this moved sides, always be careful about the signs, 4/5x. That equals, so when the positive 3/2 comes to that side, it becomes -3/2. And then, so the left hand side, so we're going to take 5/4x plus 4/5x, punch that into your calculator. Right, I suspect that this is not going to be a very pretty number. 41/20. 41/20. This is what I get for coming up with questions in my head. All right, cool. So divide both sides by 41/20, because remember the goal is to isolate your x. Right, so this is going to be divided by 41/20. If you punch that into your calculator, 41/20, that gives you negative, so x is equal to -30/41. I'm going to keep it as a fraction, right? However, just if you turn it to decimal, it's 0.731, all right? Which, yeah, essentially that's our x coordinate. Now, this is not the end of the question, because if we go back to the actual question, it says calculate its coordinates. The word coordinates, so this is an important thing just to remember, especially for your exam, because a lot of students will calculate your x or the y and then leave it. But remember, the word coordinates mean you have an x value and you have a y value. So in this case, they're actually asking for your x and your y for that specific point. So we're going to go back and say, okay, we found the x. Now let's find the y. Now in order to find the y, we're going to take one of these two equations and plug the x back in. I'm going to use this one because it's easier, right? So that's y is equal to negative 5 over 4. Was it 4 over 5x? It's 4 over 5x. All right, so don't be like me. Don't make mistakes. All right, so 4 over 5x, that's equal to negative 4 over 5 multiplied by x. But remember, your x is negative 30 over 41. So we're going to throw that into our calculators. Multiplied by negative 4 over 5. That gives us positive 24 over 41. That's your y value. Again, this is also a very ugly, bit of an ugly number. Just to check, so 24 over 30, that's 0.585. Does that make sense in the context of our graph? It kind of does, because this xy intercept is 3 over 2. So to see this, this is kind of below that. I guess it makes sense, right? As long as it's between 3 over 2 and 0, that's fine. But I'm still not very happy about, the answer. Just to make sure that we are a little bit more confident in our answer, what we're going to do is we're going to take the answer and verify, because remember, we used this equation to find that y. But let's plug x back into here and see if we get exactly the same answer, because y should be equal to positive 5 over 4 multiplied by x plus 3 over 2. This should also give us the exact same y. So 5 over 4 multiplied by x, your x is negative 30 over 41 plus 3 over 2. That's equal to, again, calculator work. All right, plus 3 over 2. That gives us 24 over 41, positive 24 over 41. So it works for both. So I think it's less likely that we've made a mistake. In fact, I actually had to redo because I had forgotten this positive over here. So this negative, I made it positive, went back to the, solved the whole thing, got to the end, realized this step wasn't making sense, and I had to redo. So I hope that's the only mistake and I've caught it. But if I've made any more mistakes, please do let me know. All right, so those are your coordinates. Your coordinates of that point are negative 30 over 41 and 24 over 41. Okay. Now, the last part of the question says calculate the shaded region. Now, this one is the tricky part of the question, right? And to make it even worse, we've got bad numbers to work with, like fractions like 30 over 21. But what should we do in this case, right? So let's look at the shaded region. The shaded region is this green shape over here, right? What shape are we working with is the first question. The shape is a triangle, but more specifically, it's actually a right angle triangle, right? Because remember, this is perpendicular. So it's 90 degrees on this side, but it's also going to be 90 degrees on that side as well, right? Now, why is it being a right angle triangle important? The reason is because if you have a right angle triangle, you can just apply, right? So if I have this side, if this is my right angle triangle, I can use this as my base. This is my height, because your height is always going to be perpendicular to your base. It has to be perpendicular to your base. The moment we have two lines that are at 90 degrees to one another, we can treat one of them as the base, one of them as the height. And if we do that, then we can use the formula area is equal to half base times height. So in this case, if this is our 90 degree triangle, right, or this is our 90 degree angle, we can treat this as the base, this as the height. It's the exact same situation where we have this base over here. We have a line that's perpendicular to it. You can treat that as your height. So it's kind of like maybe, if I flip it around, if this is your 90, this can be your base, this can be your height. Hopefully that makes sense, right? So what we need to calculate that is we need this height, we need that base over there, right? We need those two lengths. And the moment we're asking you for length, that means we can use the equation for length of a segment, all right? That means we need this point, point B, we need point O, we need point A. So let's just write those down, all right? Area of the shaded region. So I'm going to redraw, right? I'm going to redraw the shape. The shape looks like this. Let's pretend that this actually is a right angle triangle. This was point A, this was point O, this was point B. So we know the coordinates of point O. It's 0 and 0. Perfect. right? We know the coordinates of point B. I mean, actually, do we know the coordinates of point B? I think that was one of the first questions. Oh yes, that's the previous question, right? So those are ugly coordinates. Negative 30 over 41 and positive 24 over 41. Right, so we know those coordinates. We know the coordinates of point A, right? Do we actually? The x value is, the y value is 0 because it's on the x-axis, but what we don't know is the x value, right? So coordinates of point A, actually, let's just actually take a step, right? I just realized that I jumped the gun. Why am I getting coordinates? Remember, if you want to find the length of a line, so let's say, for example, we want to find the length of this line over here, right? In order for us to find the length of a line, we take two coordinates, the two coordinates that are separating them. You want to make one of them x1. Ooh. One of them is going to become x1. The other one is going to become x2. One of them is going to become y1. The other one is going to become y2. And then the length of the line becomes the square root of the difference in your x's squared plus the difference in your y's squared. So in order for us to find the different lengths, we just need to use that equation. So which means we need the coordinates. The only coordinate that we're missing here is the x coordinate of point A. All right, so hopefully I didn't I haven't lost anyone just yet. I know the question is long, it's complex, but I'm hoping you're sticking with me. Okay, so the coordinates of point A, right? So now what is the y coordinate of point A? Now remember, point A is on the equation. Y is equal to 4y, or let's use this one. Y is equal to 5, positive 5 over 4. I'm going to say y is equal to positive 5 over 4, x plus 3 over 2. I think that was the equation. Yes. Okay, right. So now how do you find the equation? Which, remember, we're looking for the x value when y is equal to 0. So we're going to say, okay, set y to be 0, and then we're going to calculate the x. 5 over 4, x plus 3 over 2. So we're going to take the 3 over 2 the other side. It becomes negative 3 over 2 as equal to 5 over 4x. Divide both sides by 5 over 4. And if you throw that into your calculator, negative 3 over 2 divided by 5 over 4, that gives you negative 6 over 5. That's your x value. So that's the x value for this negative 6 over 5 for that point A. So the reason why we're doing this is we're saying, okay, we're trying to find area. Area is going to be equal to half base times height. In this case, our base is going to be line AB, right? So that's going to be half of the line AB multiplied by the height, and our height in this case is OB or BO, right? That means now we need to find those separately. So line AB is going to be equal to, right? So I'm going to draw these kind of like separately over here. We have this line. We have B, we have A. A is at negative 6 over 5 and 0. B is at negative 30 over 41 and 24 over 41. Right, so we're going to try to assign numbers, right? So this is going to be our x2. This is going to be our y2. This is going to be our x1. This is going to be our y1. Right, cool. So the equation then becomes, because remember it's r is equal to square root of the difference of your x's squared plus the difference in your y. So we're going to just do exactly that. The difference of our x's is negative 30 over 41 minus negative 6 over 5. And then you're going to square this. Plus the difference in the y's is 24 over 41 minus 0 squared, and you close this. All right, be careful with the signs, especially for this at this point over here. All right, so we're going to throw that into our calculators. negative 30 over 41, minus and a minus, that gives us plus 6 over 5 squared plus 24 over 41 squared. That gives us an answer of, so now in this case, I'm actually just going to write them as decimals, 0.7496. All right. And then the line BO is exactly the same, right? So now we're not going to do the drawing the lines again, right? So now we're just going to come into the equation. We know we have to subtract the x's, right? So now what's the x value of point B? You subtract it from the x value of point O, which is 0. That's convenient, right? So we're going to say negative 30 over 41 minus 0. You square that. That's your difference in your x's. Plus your difference in your y's. That's going to be 24 over 41 squared. Squared. All right. Punch that into your calculator again, right? So that's 30 over 41 squared plus 24 over 41 squared. That gives you 0.9370. So finally, your area, which is half base times height, is equal to half of your base was 0.7496 multiplied by your height, which is 0.9370. Apologies for the noise in the background. So if you punch that into your calculators, you get 0.351. Okay. All right. So essentially, this was just a question that I had just pulled out of my head. It ended up being very chaotic, but I'm going to label this a very, very, very hard question. Just to show that, okay, sometimes you can join different concepts together, but hopefully it did make sense and I didn't lose any of you. All right. So let me stop this right here and I hope I see you in the next video.